Hello everyone, today we're going to be taking some of our Algebra 1 review that we did yesterday and extending those ideas to Algebra 2 topics. Same idea, just Algebra 2 topics now. So the first one is graphing quadratic and absolute value inequalities. So we have to remember everything about our parent graphs that we just learned in Chapter 4 and the review that we did yesterday. So here are our steps. You're going to follow the same steps as you did in Part B of the notes from yesterday, graphing two variable linear inequalities. But instead of the graph being a line, the graph will be a parabola or an absolute value of v, depending on whether you have a quadratic or an absolute value function given to you. So it's really pretty simple. You're just going to have a different shape on your graph now. So here's our example. We have y is greater than x squared minus 5. So that means we have a parabola that shifted down 5 units. I have less than my sine. So that means I'm going to have less than my parabola this time. Doesn't rhyme quite as well, but it still works. It would be a dotted parabola. I'm moving that vertex down 5, and then I'm doing that regular parabola dance where we go left 1, up 1, right 1, up 1. Left 2 up 4, right 2 up 4, and I'm also going to do left 3 and right 3, and if I do that, 3 squared is 9. So from the vertex, I'm going left 3, up 9, and right 3 up 9 to get my parabola. So now I do need my shading because it's an inequality. So I can do that again one of two ways. I can use that test point way, or I can use the logic way. If I decide to use the logic way, I want my y values to be greater than, my greater y values to be shaded, because it says y is greater than. So if I look at my graph, my parabola kind of splits the graph. Inside that parabola would be all these up here. So I have y values of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to infinity technically, because all those y values would be shaded. Outside the parabola, I have all those negative y values. So which are the greater y values? Inside the parabola would be my greater y values. So therefore, inside the parabola is what needs to be shaded. So again, if you don't like that logic way, you can use the test point way. So if I am choosing a test point, I could use 0, 0. If I plug 0 in for x and 0 for y, I get 0 is greater than negative 5, which is a true statement, meaning 0, 0 needs to be in that shaded region. So again, that means this shading should be on the inside. Again, you do not need to use both ways. You can use the logic way or the test point way, whichever way you like better. And again, just like before, the solutions are in that solution region. How about you go ahead and pause the video and try the next example here. Y is greater than or equal to negative absolute value of x plus 2. Alright, welcome back. Hopefully you had a chance to do that. You should have gotten this as your answer. The absolute value of v is flipped and shifted 2 units to the left. And then since I have a greater than sign, the greater y values need to be shaded, so that is going to be actually outside of the absolute value of v, or you could use the test point as you see here. Alright, the next part of our lesson is graphing systems of inequalities. So that means we're going to have two inequalities that we have to graph at the same time. So to do this, you want to make sure you get both inequalities in y equals form. Again, it just basically means get the y by itself. You're going to graph each inequality as you usually do, just like the steps from above, but you're going to lightly shade each solution region. You're not going to do it darkly, very lightly shade each region. The region with the double shading is the solution for the system of equations, and this part is the part that needs to be shaded darker. That double shaded region is the only part that really matters. So let's go ahead and graph these. Here's our example. We have y is greater than or equal to negative x minus 1, and that is my black line here, slope of -1, and a y-intercept of 0, -1 as well, and it would be a solid line because it's equal to. Now I also have y is greater than or equal to x minus 3, so I have a y-intercept of -3 and a positive slope of 1/1, and I do have a solid line there. So from there, what I'm going to be doing is needing to figure out where the shading goes. So you can do it again the logic way or the test point way. I'm going to try doing the logic way. So in doing the logic way, I'm going to figure out where the shading needs to go for the black line first. So I have a greater than inequality. So if I'm looking at my black line, my greater y values are up here. So that means everything over on this side of the black line would be shaded very lightly. So you can take your pencil and just very, very lightly, or just put a couple lines like I did. For the blue, the second one, again, I'm looking for those greater y values. So as this line splits my graph, my greater y values are up here. So therefore, my double shaded, or sorry, the shading for the blue would be on this side. The only part of this system, this graph that really matters is the double shading part. So down here I have no shading. On the left of this X I have only blue. On the right of this X I have only black. But at the top of that X I have black and blue together. So that is my shaded region. You can actually erase all the non-double shaded part. And then take your pencil and shade the double shaded nice and dark, because that is your solution region. And then when it says name two solutions, you can name any two solutions that are in that double shaded region. It has to be the double shaded. Go ahead and try this second example on your own. Just be careful, this is going to be a parabola now first. So you're going to have a parabola in a line, shade as normal, find that double shade and make it darker. And then check your answers within your group. Alright, and the last section today is writing an inequality from the graph. So again, you can use the logic way or kind of the test point way. The directions are for the test point way. I'll also show you the logic way as well. Step 1 is to determine the equation for the graph. Do not put the inequality sign in yet. You are then going to pick a point in the solution region and substitute it in for x and y. Simplify each side until you have only one number on each side. From there, you can insert the correct inequality, and then write the inequality inserting the correct inequality symbol in the end. So we will do this middle example together. So I'll show you, first off, I'll do this line I'm tracing in blue, the step-by-step way that we have above. So I can determine that my slope is -1/2, so I have that in for slope, my y-intercept is 2, and for right now I just put a blank in there. No equal, it's not equal to because they're shaded, and I'm not quite sure which inequality it's going to be. So that's what I'm going to do first. I then find a point in the solution region. So in the shading region, 0, 0 is in there, but anything that has to be in the shaded region you can plug in. So I'm going to plug 0, 0 in because it's easy in the shaded region. I'm then simplifying that so I only have one number on each side. I already only have one number on the left-hand side, is 0. I'm then going to take this and make it one number. So 1/2 times 0 is 0, 0 plus 2 is 2. I end up with 0 is blank 2. Well, what inequality needs to be in here? Well, 0 is less than 2, and since I have a solid line here, I would need less than or equal to 2. So that gives me the inequality. Y is less than or equal to negative 1/2 plus 2. Alright, so that's how you kind of have to do that. Then, if it's a system, like this one is, the first example is only one line, so you'd be done. But when it's a system, you also have to do it for the second. So I'm going to trace this one in green. Alright, I'm going to do this one the logic way. So again, you decide which way you like better. So again, you first have to determine the slope is down 2 over 1. So that should be negative 2x. And then my y-intercept's negative 3. And again, I look at this line. I'm looking at the y values of the line. Which y values are shaded? Are the larger y values shaded? Or are the smaller, lesser y values shaded? Well, obviously the larger y values are the ones that are shaded. So this would have to be a greater than symbol that goes in because the greater y values are shaded. And it would be equal to, because it's a solid line. Alright, and that makes our second inequality. Y is greater than or equal to negative 2x minus 3. Alright, once you have these notes completed, make sure you do these other two examples, example 1 over here and example 3 that I kind of covered up here, and then you can get your homework once they are completed.